Okay, I'm sorry for the delay because of the projector problem. It frequently happens, so I'm not surprising to have such a. Okay, so our first announcement is that we are going to have exercise lab using Oracle account. So you should. Is there anyone who get the email from the Omar regarding to the Oracle account? Nobody? So you will get the information about your Oracle account soon. So right now we are not going to use any Oracle database or the Oracle account, but we will use it. But sometimes the student just forget and throw away the information. So to remind you, so first assignment will be the pre-project assignment, which require to log on the Oracle database using the Oracle account given. So you will you need to use that Oracle account to log on the database, then check what's going on. But at the time you don't have to worry about it, even though you do not know how to use the Oracle database. Just check the validity of your Oracle account and password. Then you will use that account for future exercise lab. Okay? Any questions so far? We are discussing about what is the database. Is there anyone who can say what is the data and what is the database? Anyone?
Data
Yes.
is the facts.
Fact.
The facts can be recorded. And the database is a collection of data.
Yeah, database is a collection of the data, but what about the data?
It's related data.
Related data? What's the relate? Relate what? Yes, that's true. That's the related information. So, suppose that we have a bunch of information to be managed. So here, even in the classroom, you can find a bunch of the information, but we are not going to manage all the information in the computer system. Instead, we'd like to find some related information. At that time, you can say related information, related data. For example, I'd like to manage and keep track of the student information, student data. At that time, the student, information about you, information about him, information about her are related. Related to how? It's a student information. Especially, I'd like to keep track of the name, last name, and first name, and the phone number. What else? The major and social security number. I'd like to collect only those information. I know you have a bunch of information. He has a bunch of the information. He has black hair and brown eyes and wearing the blue jacket. But we don't care. We are not going to manage it. It's not related to the student data. So at that time we can say student data. So when we are saying the data, yeah, it's a little bit controversial. Somebody said information and the data are not much different. But in my class, I'd like to say the data is the information are everywhere. Sometimes there is no specific the rule or the format. But the data is formatted. It's the structured data. As I mentioned several times, or emphasized on the last time, the data is the structure. Structure means somebody make the rule. What kind of rule? It's an algorithm in terms of computer science. Because we are going to eventually use a computer. Why do we need to design the database? Is it for just hobby or the tasting, whatever? No, it's only for computer. We'd like to build a computer system to manage the data. To do that, we should have very strict rule. That is the related or formatted or designed. So eventually, it is called the data model. So we will learn such a data model to build the data. Then collection of such a data, we can say database. So if you build such a data in your mind, design or imagine or draw, that is a conceptual database design. At that time, you don't need any knowledge on the computer. You can just, so you are asked to build the database of student conceptually. At that time, do we need to use the computer system? No, you can just throw the student. I have the student. I decide the name of this database. Then to manage the student data, I need the last name. This last name will be string. So maximum 100 byte. And first name. First name is a string and maximum 100 byte. Social security number is 9 digits. 9-digit number. So we designed such a thing. At the time, do I need anything about the computer system? No, it's just conceptually designed. Even at the time, we don't need such a thing. Just I try to keep your last name, first name, social security number. That is a reason sometimes, so most of the time, the conceptual design can be done by who? Designer or model, or sometimes financial advisor, not computer scientist, not the developer. Okay? Because at the time to design this one, do you need the program language knowledge? No. The more important thing is domain knowledge. Whether you know about the student, whether you know about the company, whether you know about the process of the manufacturer. That's much more important. That is a reason sometimes, do you know the CPA, Certified Professional Accountant? CPA sometimes can do database design, even though they do not know anything about the database. That's a conceptual design. That's much more important first time. Okay? Without knowledge of such a domain, it doesn't make sense to build a database. So that's one thing you keep your mind. That's the reason sometimes the interdisciplinary knowledge is very important. For example, technical management and computer science skill, or the business major and the computer science. Why? The money is the most important one. If you know the money flow, where the money is going, then you can, the building a system, programming, is just piece of cake. So when you design the database, you should keep in mind. First, to conceptually design the database, such a domain knowledge is very important. Then the computer skill is the next one. But we try to focus on such a little bit about the conceptual design, how to collect, how to build the database, then how to build the database on the computer eventually. Another thing is I mentioned about the information and the database. I have a question. So I'd like to search how much the air flight fee to go to Orlando, Florida. I'd like to have a vacation. So at the time, what you guys do usually? Search Google. Or sometimes you have you visit the TripAdvisor or the Expedia.com, something like that. At the time, do you search the information or do you search the data? Which one? It's the information. Sometimes it's on the HTML file. Sometimes it's in the PDF file. Sometimes it's in the just the plain text. But Google can search most of the data, then show by length. At the time, you can say that is information retrieval. However, you are going to use Expedia.com only. So Expedia.com has a very fancy, nice storage to keep all the information about the flight schedule and flight fee and the time departure and the arrival time. At the time, that is called database search. So you can use the database search. So database search and information retrieval are a little bit different, not the same. But nowadays, both of them are very important. Usually, information retrieval deal with unstructured or semi-structured data. While the database search engine uses very strictly structured data. In other words, it has the something database model. So we will focus on such a database model in our class, not the information retrieval system. Okay? But nowadays, information retrieval and the database search are working together because it's very hard to separate two distinct the search. Okay? The last class we have discussed about the direction of this class. Then we will eventually cover some important topic in the database engines. Then, by the way, what is the DBMS? Database Management System, for example, Oracle and Informix DB2 is a software. So we are not going to learn how to use software. Did you take any class how to use the Microsoft Word? No. Do you take any course how to use the PowerPoint? No. We are not going to learn how to use the software. You can do that by yourself. If you understand the theory, basic idea, fundamental of the database design, database algorithm. So DBMS is a software that supports such a database engine. Sometimes some of the software support specific model. For example, relational database model. That's called the relational DBMS, RDBMS. So probably many of you guys heard about RDBMS, Relational Database Management System. Okay. Sometimes there is an object-oriented database system. That's called OODBMS. There are a bunch of different software, For example, for presentation, PowerPoint is the only software to present. No, there are a bunch of others. The PowerPoint is just one of them. Okay? So you don't have to spend the expensive money to learn how to use the PowerPoint. You can do it by yourself. If you understand the basic of the Windows or basic of the software application. It's the same thing. Oracle, Informix, DBS, the DB2, any DBMS software, they are based on the same model, relational model. So we are going to learn to understand the relational database model, not software. Okay? But it's true. It's a little bit complicated programming. It's not like the PowerPoint. It's not like the MS Word. That is the reason after we cover this part, we would have the exercise lab. I'm going to balance between the theoretical approach and practical skill. To get the practical skill, we will have the exercise lab. At that time, I'm going to select the Oracle DBMS. I'm not the salesman. I'm not a big fan of the Oracle database. The reason why I select the Oracle DBMS is it's the most popular. So when you graduate, then you get a job, many of the company will use Oracle database as a DBMS. So that is the only reason to select the Oracle database. Okay. There are several characteristics, important characteristics why we use the database. First one is the self-describing nature. What does that mean, self-describing? What is the other approach if you decide not to use the database? How can you manage the data? How do you manage the data without DBMS? On your computer. Do you have data on your laptop? Yes. How can you manage? Where do you save? Folder and file. It's called the file system. So file system is another way to manage, and you can search the file, right? So that is another approach. But comparing to the file approach, file system approach, database has the self-describing nature, which means, so you can use the file to keep track of student data. How can you? So I have 45 students. So for 45 student names, write down name first, then the phone number, others. Sometimes he's handsome, whatever. Then next one, I do not know the phone number, just the name only. Or first name only, that's it. Third one, I know student very well, all the information about student. Then when you search specific student, it's very hard to find, especially when you have many students. Also, you don't know how each student is organized. Sometimes it has a first name and phone number and whatever, and sometimes it's only the name, sometimes a bunch of information. It's not well organized. Also, it's very hard. Also, if you build an application to access this data, you need to read each and every byte, then get the data and extract the first name only, last name only, and so on. So it's not very convenient. However, using the DBMS system, database system store some information about last name. In the database, last name has a string, 100 byte. Next, first name, string 100 byte. Social security number is a number 9 byte. These structures are already stored in the database with the format of database. That means all information about the data structure are stored, managed in the database also. That is called self-describing nature. In other words, when you access the data or database, for example, student database, you don't have to try to understand how the file is organized. No, you don't have to do what? It's already in the database. So you can just access this information. Then you realize this student information are stored with the last name, first name, and social security number. Last name is 100 byte, first name is 100 byte, and social security number is a 9-digit number. That's it. You don't have to ask others. So that is called the self-describing nature. In other words, that is called catalog. Catalog information or catalog data. That's very important when you are using the DBMS system. If you understand how the catalog is organized, I think the 90% are done. So in your second project, project B, build oral access menu-driven application, at that time you need to use a lot for catalog information. Okay, we will have a time to discuss about it more. Next, insulation between programs and data. So let's go back to the file system approach again. In your file system approach, how can you access this file in your application program? You need to code. So for example, main function first open. Fopen, this file is a student.txt file. Open the student.txt file with the read format. Then read the byte by byte, then get the name, something like that. Yes, you can do that. It's not very complicated programming. What if next time I change the little bit format, like I'd like to add the address over here. What happened to your program? Is your program still working? No, format is different, so you need to revise. That's it? No, you don't. You should compile again. Then make the new executable file. Well, whenever your file format is changing, this is the problem of the file system approach. What about the database? Database, you manage all the information in the catalog database. So for example, I'd like to add address. Address is a string, 1000 byte. And it will be updated. String, the address, 1000 byte. In your program, database program, you access last name, social security number only from student information. Do you need to change this one? No, you don't have to change. Only this one is changed, but program level doesn't matter whether there is a change or not until, for example, last name is removed. Then you need to change. There might be error because the last name doesn't exist. However, if you change it, if you add some column or some format, it doesn't matter. So that is called program and database are separate. It's an insulation. So insulation between program and data. They are independent. That's a huge benefit. But when you are using the file system on your computer, you should know all the format and organization. But when you are using the database itself, DBMS, that is the benefit of using database. Manage such a thing. So you don't, in your program, you don't have to worry about it. That is the insulation or independence. That's a huge benefit, actually. So you will have a chance to access such a catalog database during the exercise lab. Also, in your second project, you will use a lot the catalog information. What's the format of such a catalog database? It's also a database. So it's not very difficult. Another interesting characteristic of the database is the multiple view of the data. Let's take a look at this student information also. So in our class, we have the 45 students. Some of them are majoring in computer science, the others are computer engineering, and also we have the non-CS major student. But each department, each program has the advisor. They try to access the student data about the database course. But, for example, the CS advisor doesn't have to access non-CS student. Okay? So this is, so we have the data of the student. This is a CS, this is a C, it's a non-computer related. So advisor of the CS access only CS. Advisor of the C access this one. Advisor of non-CS access only this one at that time. Using file approach, we need to create the separate file. Yes, we can do that. The more serious problem is, for example, financial department would like to access some social security number. Payroll office. Payroll office would like to access the social security number only, but not private information. At that time, I need to create some small file only for payroll. Sometimes the registrar office, you should manage a bunch of different files of student. It's not easy. For example, my information is in the payroll office student, and my information is a computer science advisor. My information also in the registrar office. So I move, so I got the new address. I should inform each and every department who are managing the student file. Sometimes forget. So your information will not be consistent. To address that problem, database has only one file structure for student, then support different view. Physically, it has only one file, one storage, but it can be viewed as differently. That is another benefit of the database. Also, it can provide very nice consistency. Consistency means when I move new address, I can inform to only the one time to the database admin. Then, when my address is changed, all the other will see the updated one. That's the benefit of using database. So that's called the multiple view of the data. Also, another huge benefit of the database is multi-transaction, supporting the multiple transaction. For example, I'm comparing the characteristic of the database with the file system. File system, So you can open the file to manipulate the data. At that time, can the other transaction open this file? No, even when you are using the PowerPoint. So I'd like to, I open the PowerPoint and revise, so add, create the file. At that time, can you reopen the file? No, it can be opened as a read-only. Most file system does not allow the multiple transaction to update the data at the same time. Only one time. The others will be read-only. That's a serious problem. When, for example, the student would like to update your data, but if you allow only one transaction to update the data, for example, he access the student table, then he didn't complete the transaction, just take a nap, and all the other students should wait until he finished the transaction. It's not serious on the university, but think about the stock market system or any auction system. That's very time critical. So DBMS supports such a multi-user transaction, which means multiple users. Many users, one or more users can update, delete, and manipulate the data at the same time. Okay? Especially Oracle is very nice for such a multiple transaction. That is the reason many of the companies select the Oracle database for their, it's called the OLTP, Online Transaction System, like the online market or the stock market system, banking system is very popular. Okay. There are different types of user, but nowadays that's not very important. I'm going to skip the history of the database. You can read the textbook, then easily understand the history of the database. Then, Professor Lee mentioned about the many times the benefit or the characteristic of the using database. But I have a question for you. So, is the database approach is the best solution to build a system? What do you think?
Depends on situations.
Depends on. I like the answer, depending on. So depends on what?
The size.
So when not to use the DBMS?
Smaller size.
Small size. That's a good answer. As I said, database has been developed for what?
Larger.
Very large data. When you have a small amount of data, just forget about the database. However, sometimes you use the database in your programming class. Why do you use program? How many rows did you insert? It's 10 or 20. It's for your practice only, educational purpose. But if you build a real system, like I graduate and I build a company, programming company to build a small, medium-sized business. Like some grocery store or some bakery or whatever. At that time, Professor Lee said the DBMS is very nice. So you suggest your customer to purchase the DBMS, Oracle DBMS, which costs almost $1 million. Yeah, that's it. I can afford the $1 million. The more serious problem is maintenance fee every year. You need to pay 20% of the purchasing price. For example, if you purchase Oracle with $1 million, every year you should pay $200,000 for maintenance. Which means even though you didn't do anything throughout the year, you should pay 20% of the price. It's very, very expensive. Okay, so when you have a small, so the size of the data, you don't have to use. Also, if your data
It's related. It's not related.
not related, not complicated data. if your data is not complicated, for example, I have the huge size of the data, but that is just the customer information. I have the 10 millions of customer, but it's a simple. It's nothing but customer. At the time, file system approach is much easier and cheaper and also faster. I never say database approach is faster than file system. Actually, file system is faster. Why?
Because it's
Within
simple.
the direction.
Yes, simple. It has DBMS. DBMS, Professor Lee says 1 million. That means it's very complicated and huge software overhead. Actually, the Oracle, when you install Oracle, it requires at least a 4 gig memory size. At least. It's much bigger. Actually, when I met the Oracle first time, it was 1995. It was very small, so you need only the several hundred memory. But nowadays, it's much bigger. It's overhead. Okay. Also, another big problem is it's slower sometimes. Also, another big problem is hard to manage. For example, so I just skip the types of user. There is the database administrator who manage the database DBMS engine itself. Because database is very critical, very important, there should be someone who watch and manage, monitor this system only. This guy, payroll is very, very high. So even you cannot afford the payroll for DBA, database administrator. So many of the small, medium-sized company, they do not hire. There's no one to manage this kind of the database, even though they possess the database with a very expensive amount. So one time, I was asked to check up the existing database in small company because the company never ever hired the database administrator. So when I log into this system, I cannot understand the database. Why? The table name is just the T1, T2, T3, T4. And column name is C1, C2, C3, C4. And there's no relationship, just create a table and some of them are garbage data. Never ever managed. So that is another big problem. So I suggest, why don't you use just a file, throw away the database. So DBMS is not always the best solution. Okay? But still, we need a database when you have a very large database. Also, when your system database are very, very sophisticated, complicated. At the time, we can use such a database approach. Then, these are the chapter 1. Then chapter 2 is the database system, concept, and architecture. Is there anyone who ever used a database before, even in classroom or anywhere? Yes? MySQL. And anyone else? SQL Server in your programming class? Yes. So database management system are nowadays very popular. When you are using, why do you use the MySQL or SQL Server in your programming project? Why did you use? What is the main purpose of using database? To retrieve the data, you can use a file system. Plain text file, that's much faster and easy to. You don't have to design or whatever, just create a file, then put the file, write the information in your file. We already discussed about it. One reason is to manage the large data. Okay? But when you manage the very large amount of the data, what can be the problem? It's hard to manage. And then another problem is redundancy. Yes, that's management issues. It's very hard to manage the redundant information. Search, yes. When you have the 10 student, 10 customer, it's easy to find who is who. But when you have the 1 million of customer, it takes a long time. Even though the customer names are sorted, it takes a much longer time than 10 customer. So when you are using the database, when you select the database, so you should pay attention to how fast your system is. If your database system, no matter what types of system you use, if it takes longer time to access the data, you can just throw away, find another solution. So one important reason to use the database is search the data, retrieve the data very fast. But that's different from what Professor Lee said here. Accessing data using the file system is faster, right? But now Professor Lee is saying DBMS should be fast. Database approach should be fast. How can you understand this paradox? I said file system approach is faster than database approach, but DBMS should support fast approach, fast search the data. Actually, DBMS itself is not faster than this one, but because of the couple of important components, it can be faster than file system. The first one is, how can you look up the data very fast? For example, textbook? Any textbook? Anyone who has any textbook? Doesn't have to be database. Yes? So I'd like to look up functional dependency here. How can you find the functional dependency?
Index.
You can go to index. Where is the index? At the end of the chapter, you can find how the index items are organized. It's a keyword plus page number. So also keywords are sorted by alphabet. It's alphabetical order. So you can easily find the F, then functional dependency, then that's the page 431. So you can find the 431. How can you find the 431? It's ordered already. Page is not like the 102. It's already ordered, so you can do the binary search because you are computer science student. Binary search. Cardinal half, cardinal half. No, I don't do that. 400 is. Anyway, you can find. So that's the fastest way. Or if you do not know about the index, you should check each and every word from the beginning, which is called sequential searching or brute force way. It's an algorithm, actually. Okay? So it's a linear search. So which way is faster? So indexing approach is faster. Without index, this one is slower than file system. But since it has indexing, so this database has an indexing structure. What is an index actually? It's a data structure also. For what? For fast retrieval. For accessing the data very fast. It's a slight, huge different from the actually file system. It's a indexing structure. Actually, indexing structure used in DBMS is 99% same as this structure. We will learn probably after midterm exam. Okay? Another way to speed up accessing the data using DBMS is, any guessing? I will give the extra point.
So,
What? How can you speed up to access the data?
sorting.
Sort is already considered index. Index is the sorted. Sorting of the keyword.
Primary key.
Primary key is, he knows everything. So actually, primary key is part of indexing. Okay?
Hashing table.
Hashing table, it can be part of the answer, but not the exact answer. Anyone?
Relations?
I already mentioned about it just before.
Relations?
No.
Cache.
What?
Cache. CH2.
Cache. Yes, he's right. Let me know when after class. Cache is another way. I mentioned about right now the Oracle require at least 4 GB of the memory. So another way to speed up to access the data is accessing data from the hard disk drive. So still slow. Why don't you put most of the data, not most of the data, actually small part of the data to the memory. Then it will be much faster. So, but somebody argue, I have 1 TB data. Do I need 1 TB size of memory? No, you don't have to. Even I have the 1 GB size of the memory. That's enough. Why? There is a rule. Only 5 to 10% of the data, entire data, only 5 to 10% are used frequently. The other is just a history. Never used. For example, why don't you go back to your room and you have a bunch of the books on your bookshelf. Do you read all the book every time, every day, even every year? After you read it, usually it's just decoration, right? 90%, 99%. Only your diary or some important one we frequently check. That's the exactly same in the database. We do not read all the data, only small part of the data will be accessed. Any type of data, same. So, 99% of the data can be read from the memory. Only 1% from the hard disk drive. That is a huge benefit to speed up to access the data. 2 reasons. One is indexing structure, another one is memory. It's a buffer management, actually. So it's called the buffer. It's the same as the cache. So because of that, accessing the data using database is very fast. Okay? So because of when you decide to use the DBMS, please first think about how fast. Depending on the type of the data, sometimes Oracle is faster, but sometimes the DB2 is faster. For example, Oracle is good for online transaction. It needs very fast response time. If you do not know what is the response time, why don't you go back to your home, then open your operating system book. It will show what is the response time. And on the other hand, data warehousing system. Data warehousing is a warehouse. It's the storage, big storage to keep all the data. It's usually bulk processing. It's a batch processing. At that time, the DB2 or other DBMS is faster than Oracle, something like that. So that's the characteristic of the DBMS approach. Then this chapter we will discuss about the database architecture and concept. So throughout the semester, not throughout the semester, first half of the semester, we will learn about the database design. When we design the data and database, we should have something rule, right? So do I need to design whatever I want? No. We should follow very, very strict rule. Why? We are not going to design like the house. We are not going to design like the building. At that time, the preference, or sometimes you have the favorite type of house, you can do whatever you want. But the data design should follow what? Data structure. Because we are going to build the data and database on a computer, not in my backyard, not in my front yard. Okay? So computer, as I said, can understand only their own language, their own type, their own data structure. Okay? We should follow this rule that is called the model. data model and database model. Especially data model is the collection of the rule to build the data. Sometimes you say it's a related data. What is a relation? That relation can be defined in the data structure. That's called the data model. Okay? Actually, you learn the computer science and computer engineering algorithm based on such a structure, such a model. Sometimes it can be called as a model, sometimes not. When we are saying the model is a collection, very large, the rule or the format or the structure. So especially the database is called the data model. Data model usually has the operation and constraint. Operation is how to manage the data, insert, delete, create, and something like that can be defined. Also, constraint is the condition, how the data are related. That is a constraint. Especially in our class, there are a bunch of different types of the data model. Among them, we will learn about ER data modeling. ER stands for Entity Relationship Data Model. By the way, have you ever heard about the relational database or RDB? Yes? RDBMS. Probably you heard of, even though you do not know what that is, you heard about the RDB or the relational data. What R stands for? What does R stands for? Relation. What does that mean, relation?
Something to do with another one and with
It's a relationship,
multiple database,
collection, connection,
multiple database, relation between
structure. Yes, it's a structure. Yeah, everything is a structure. When we are saying relational database or RDB, R stands for relation. Relation means a set. Do you know what is a set? Why don't you go back to your elementary math? You learned about the set, right? Set is the, this is a natural number set, like that. It's a set. Set is defined as what? Collection of elements. So similar as the database. Database is a collection of data, right? So someone is actually the Dr. E.F. code. He adapted the employee the idea of set theory to the database model, data model. So when we are saying the relational database, RDB or RDBMS, R stands for actually set in mathematics. So math is very, very closely related to any computer science subject, especially in database. Actually, my undergraduate major was mathematics education. So I tried to be a math teacher in junior high or the high school. But unfortunately, when I graduate, there was the exam to be a teacher. I should pass that exam, but I didn't study a lot. So my GPA is not so good. So if you have a chance, take a look at my transcript. Undergraduate, believe it or not, my undergraduate GPA is below 3.0. I still don't understand how can I get the admission from my graduate school. Anyway, so actually I didn't have any background in the database or any computer language, any computer stuff. But when I graduate, I should get a job. So just like I'm not sure your culture, but in my hometown, South Korea, I'm the only son should support the family. But so I need to get a job. So I applied the bank at the time. So fortunately, I had the job offer from the bank because at the time I little bit study English. So because of that English point, so score, so I can get job offer. But my supervisor, who was the database administrator, selected me. as a database administrator. Only because my major was math. So I started I do not know anything about the database. So he pick on me, then he taught me a lot regarding to the database, but it's not much different from what I know before. So that's the reason. Anyway, the math is very closely related to the database.